In this video, we look at calculating the perimeter and area of some different figures. Just highlight a couple of definitions to start with. Just a reminder that the perimeter is the distance around the outside of a figure. We want to find out what is the distance it takes to go around the outside. Whereas area is the amount of space inside of a two-dimensional figure. We'll talk a little bit later about surface area and volume, but I just wanted to highlight them for you right now. The surface area is just the area of the outside of a three-dimensional figure. So if we have like a rectangular prism or a box, we want to find the surface area. We just find the area of all of the faces and add those together. So that would be an example of surface area. Whereas the volume is the amount of space inside, so the amount that the figure can hold. So that's what we mean when we talk about volume. Today we're going to focus on area and perimeter. So we have a couple of examples here. I should mention that for all the work that you're going to do, you will have access to a formula sheet. That formula sheet looks like this. So this is sort of the section that we're concerned with today on area and perimeter. There's a sort of backside to this page. It has information on surface area and volume, but we're going to focus on the area and perimeter today. So you can see that the formula sheet gives you a picture. It gives you a perimeter formula for perimeter, and also one for the area. So in multiple representations, when there are multiple representations, you can use either one. So for example, down here, the perimeter of a circle, which we often call the circumference, can be written as pi times d, or you can write it as 2 times pi times r. So let's go back and we'll have a look at this example. Here we're asked to find the perimeter and area of the following figures. So let's start with the perimeter. And we'll find the perimeter of this triangle. So in order to find the perimeter of the triangle, we really just want to know what is the length around the outside of this triangle. So we're just going to add up all the sides. So I like to put a little check mark beside them as I write them down so that I know that I've included it. So we've got the 41, pardon me. We'll do the 20 next, and then also the 35. And we can add those up. 41 plus 20 plus 35 will give us a total of, what's that, 96 centimeters. So the perimeter of that triangle is actually 96 centimeters. All right, let's move right along then. We were asked to find, don't forget, we were asked to find both the perimeter and the area. So let's find the area. So again, if you're not sure how to find the area of a triangle, if you remember, that's great. But if not, you can always go to the formula sheet. And here's the triangle. In order to find the area of a triangle, we can either do half the base times the height, or we can take the base times the height and divide it by 2. Either one of those is acceptable. Let's do base times height divided by 2. Again, if you choose the other one, you'll still get the same answer. Now, when we talk about the base, we're talking about the distance along the bottom here, which is 35. And the height is 18. We multiply those and divide by 2. So let's see if we can do this maybe all in one go on the calculator. So I'll just type in 35 times 18 on the calculator. That gives me 630, and when I divide by 2, I get 315. So that means that the area here is 315, and we measure area in units squared, so this is centimeters squared. So that's how we can do part A here. Let's move on to the circle. So the circle here, again, just a reminder, we call the perimeter of a circle the circumference. Two ways to do that one. We can either do pi times the diameter. Maybe we'll do both so you can see how they're the same. Let's try that again. So pi is just a number reminder. It's approximately 3.14. We'll just leave it at pi for now. And the diameter here is 50. So on our calculators, go to the calculator, type in 50 times pi, and we should get an answer here of 157.1, we'll call it. This is measured in millimeters. So the circumference of this circle, 157.1 millimeters. And I said we would do it the other way as well. So the other formula that was given there on the formula sheet is that the circumference equals 2 pi times the radius. So I'm going to leave the pi for now. The radius here, just a reminder, the radius is half of the diameter. So the radius here is equal to 50 divided by 2, or 25 millimeters. We can substitute that into our equation. You can see now that we're going to have 2 times pi times 25. We can do the order, the multiplication in any order we want. 2 times 25 is 50, so we get 50 pi, which gives us the same result that we had a while ago. Let's try to clean that 5 up. So 157.1 millimeters. All right, let's move on to the area. So again, if we go down to the our formula sheet for area, so there were the 2 formulas that we talked about for the circumference. And then the area is just pi times the radius squared. So let's go back. Area is pi times the radius squared. So it does have to be the radius for the area. And as we said, the radius for our circle is 25. So we'll do 25 squared times pi. And we'll just go to the calculator here to see what that gives us. So 25 squared times pi. Or you could do pi times 25 squared. I get 1,963.5 millimeters squared. Again, we're talking area, so we're talking about units that are squared. All right, so those are some basic shapes. That's how we can, again, I know that this is primarily review, but I just wanted to go over it, refresh your memories, because we're going to start to look at some composite shapes now. When we look at the composite shapes, here's what I mean by composite shapes. So basically some shapes that are made up with other shapes. Now the first thing you might notice here, we'll call this, I guess, example A. Call this A. It's that we're missing a few measurements. So it'd be easy enough to find the perimeter here. The perimeter is just all of the side lengths added together, but we are missing some measurements. So we're going to use measurements that we have. So for example, let's see if I can change the pen color here. We know for sure we want to find this side length right here. We need that side length. Well, it's made up of this side length plus this side length. To get from the bottom to the top, we have to go up 5 centimeters and then another 3 centimeters. So this needs to be 8 centimeters. So that's a little messy. Let's try that again. And then we need to do the same thing with the information at the bottom. We know that, maybe we'll do that in a slightly different color. We know that from left to right is 10 centimeters. This first bit is 4 centimeters, so this last bit has to be the difference between those two. 10 minus 4 would give us a total of 6 centimeters here. So the perimeter is just the sum all the way around. So I'm going to start with that 10 centimeters. It doesn't matter where you start. Again, I like to put a little check mark there so I know I've included it. We'll do the 8 centimeters. 4. Well, I put my check mark there. That was a mistake. That needs to be a 3. Plus the 6. And then plus the 5 again, I guess. Not again, but the last measurement there would be that 5. And then we could just add those all up. I think that adds to 36 centimeters. It might be worth just double checking that. Yep, 36 centimeters. So that's the perimeter. We were also asked to find the area, so let's go ahead and do that. Now here's the trick here. I like to use some subscripts here because what we're going to do is we're going to talk about the total area. Well, the total area here is just we're going to divide this. There's no formula for doing like the area of an L shape. So what we're going to do is we're going to break this down into shapes that we already know how to find the area of. So for example, I might just grab a pen and draw a line going down here, and then I've created 2 shapes. I've created a rectangle over here. I'll call that A1. And another rectangle over here, we'll call that A2. So the total area of this shape is just A1 plus A2. And to find the area of A1, it's just a rectangle. Rectangle, the area is going to be the length times the width. So let's go ahead and find that. Our length is 8. Our width is 4. And then for our second rectangle, be careful here. We're not going all the way across. We're only doing this bit right here, which is actually, sorry, this bit right here, which is 6 centimeters and 5 centimeters. So 6 by 5. And then we can add those two together. So 8 times 4 is 32. 6 times 5 is 30. Add those two together and we get 62 centimeters. So we're talking about area. And again, we want to talk about centimeters squared. All right, let's move on to the next one. The next one looks pretty complicated, only because of its setup. But again, just break it down into a couple shapes. We want to know the perimeter. So the perimeter is the distance around the outside. Well, we know we're going to take the 20 millimeters that's there. We're going to add in the 30 millimeters. I won't put the units in there just to keep things a little cleaner. And we know that there's another 30 millimeters on this side. And then we have to add this part up here. Let's see if I can draw this in a little bit. We need to add this part right here. Well, this part up here is really just half a circle. So really, we want to take a circle, the circumference of that circle, and divide it by 2. And so you might be wondering, well, how do we find the circumference of that circle if we weren't given any measurements? But notice here, we actually know the diameter of that circle. The diameter of that circle is this line right here, which is this 20 millimeters. So we're going to add the circumference of the circle. You can do that in 2 steps if you want. You can just find the circumference of the circle off to the side. So pi times d, and then you only want half of it, so you can divide by 2, or you can kind of work that into your equation if you prefer. So we know that the circumference is going to be pi times the diameter. Diameter of that circle is 20, and then we can kind of work that all out. I'm going to add 1, 2, and 3, those 3 things. 60 plus 20 more gives us 80. And then I can go to my calculator and do pi times 20. And get 62.8. Add those together and we get 142.8, if I'm not mistaken. Oh, you know what I didn't do? I didn't divide it by 2. That's what I didn't do. I was going to say that number doesn't look quite right. So let me backtrack a little bit here. This was 62.8, and we really wanted to divide that by 2. So let's fix that up. This is the entire circumference of the circle. Let's take that and divide it by 2. And so when I take that 62.8 and divide by 2, we actually get 31.4. So we'll tidy this up. This should be 31.4. Which will change this answer a little bit. So if we go ahead and add 81 and 31.4, we should get 111.4, and that's measured in millimeters. All right, so that was the perimeter. Next, we have to find the area. So we'll do this the same way we did before. Break it into 2 sections. We'll call this area 1 and call this area 2. So the area total here is equal to A1 plus A2. A1's fairly straightforward. It's just a rectangle, 20 by 30. The area of a rectangle is the length times the width. And then the next part is just to find the area of the semicircle. So we're just going to take the area of a circle, which is pi times the radius squared. Hang on, we need to find the radius. We know that the diameter of that circle is 20, so we know that the radius has to equal half of that, which is 10. So we're going to take pi times the radius squared, and then we need to divide it by 2 since we only have half the circle. All right, 20 times 30. Maybe I'll write a little bit smaller so we can get a couple lines in here. 20 times 30, that's equal to 600. And then this pi times 10 squared, which would give us 314 or so. And then divide that by 2. get 157.1. Let's see if I did that correctly. Yeah, I think that's okay. 157.1. Then we just add these together. So 600 plus 157.1 will work out to 757.1. And again, this is area. So we're going to talk about millimeters squared. That's how we can use, some basic sort of perimeter and areas knowledge to help us solve for more complicated shapes. Just break them down into simpler shapes that we can easily find values for.